Okay, so the idea of increasing and decreasing, the way I like to think about it, if I'm going left to right, just picture like a little car going up. If the lights are pointing upward, then it's increasing left to right. If it's horizontal, then you are constant. You start going down the hill, you are decreasing. And then here, constant. So up, the lights are pointing up again, increasing. So it's really easy to visualize if you have any graph and you're looking at it from left to right. You can visually see the slopes increasing, decreasing. And when you have a change of increasing to decreasing, you have a point of a critical point, maximum and minimum. So eventually, we'll talk about the first derivative test, and it's all based on this idea. If I go from increasing to decreasing, we have a max. If I go from decreasing to increasing, we have a minimum. And you can see why it would be minimum and maximum, right?
Yes.
So given this idea, you can have any function. So no matter how ugly the function is or how complex it is, you can find where maximums are on the entire function. So given this guy right here, I might have to adjust this thing here just a little bit. Okay. So step one, find f prime of x. So first take the derivative, right? So f prime is going to be 2x minus 6, correct?
Yes.
Step two, find the critical numbers. We talked about this on Thursday, I think it was. Find the critical numbers. And the way we do that is by setting the derivative equal to 0. Okay. Okay. So this one's pretty easy, right? 2x
Yep.
minus 6 equal to 0. 2x equal to 6. X is equal to 3. So there's my critical number. So now use this as kind of like a pivot point. Check before and after to see if it's a maximum minimum. So basically what we found probably is one of these, right? So we just want to find out what's happening before and after the 3. And we do that by testing around this point using f prime. So use the first derivative test to test around. I'm going to put that, just write down what I just said, around the critical numbers. To determine if it is a maximum slash minimum, and to find the intervals of increasing slash decreasing. So you can use you can use source derivative to find all that information, and I'll do that on the next page in just a second.
Okay.
Does that make sense though, the big picture idea?
Yes.
Yeah, I think doing the homework first, it kind of makes it a lot more simpler, I think. To follow along at least. That's what I was told. Okay. Are you cool on this page?
Yes, I am.
Okay. So let's test around it. So basically, put the 3 in the middle, test any point after and any point before. But you must test them into the derivative. So the easiest point is 0. So try out 0. 2 times 0 minus 6 is equal to -6. So we're negative over here. So if we're increasing afterward, we're going to have a minimum, right?
Yes.
Now test, let's pick 4, I guess. That'll be 2 times 4 minus 6, which is 2. So we're going downward, and then as soon as we get here, we start to increase. So you can see what's happening, right?
Yes. Okay. It does. Yeah. This part I definitely remember from taking calculus in high school.
Cool. All right. So then, since there's no more critical numbers, you can make the assumption that, I mean, there's a theorem that proves it, but because this is the only critical number, we are going to be decreasing based on the derivative below this number forever and increasing after 3 forever.
Did you hear about those two girls that proved the Pythagorean theorem using trig?
No, is it a new approach?
Yeah, they've never done it with trig before because it's considered the basis for trig. I think they use law of sines. The paper isn't released yet, but it's crazy.
That sounds interesting. You have to send it to me if you find it.
Okay.
That's super cool. Yeah, like yeah, I'll have to think about it later. So not distract me now. It's like, oh, how was it done? Sounds super cool. Right, 3 to infinity, increasing, negative infinity to 3, decreasing.
Got it.
Minimum, because we can see it at 3. We don't know the x value. In order to find that, you have to plug it into your function, the original. So plug it into, I think we called it g, right?
We called it F on the first page and G on the second.
Oh, was it f originally? Okay, my bad.
I just wrote it all as F. I was like, it's the same function.
I mean, I know you know what I meant, but when
Yeah.
this is not correct. Okay. So 3, it was a parabola, right? 3 squared. Yeah.
Minus 16.
Thanks. So 9 minus 18 minus 16. 25, right?
9 minus. So, okay. It's 18 minus 16. That's 20. No, that's 32. No, I'm wrong again. It's 34. Yeah, that's 25.
No, that's okay. Thanks for checking because I mess up too. So this number goes right there. Okay. So there's a minimum location. There's increasing and decreasing. Although the homework question, I don't think asked for that. I don't remember. It just wanted the intervals, but eventually it's going to ask for these values.
I wanted the minimum and the maximum if it was applicable.
Yeah, I think in the later questions, right? Or does the first one
Yeah.
also ask? No, not the first
Yeah, I think the first couple were just minimum, maximum, and then all the ones after that were combination of intervals and minimum and maximum
one. Okay.
and critical numbers.
Hmm. All right then. Okay. Let's find another one. I'm gonna do the next page. Have you ever heard of
Sounds good.
what's that?
It sounds good.
You ever heard of the Millennium Problems?
Are those ones that still aren't solved?
Yeah. Well, some have been solved.
It wasn't like weren't a couple of them solved by this kid that came in late and thought they were homework?
I don't know. That sounds vaguely familiar. Like, I don't know if that's urban legend or true. I
I
know.
know it's true, but I'm not sure if it's this one.
Oh, you mean like it might be a different problem? I
Yeah, it might be a different set of problems.
think these
That
are
was just hilarious.
they award you what's it called? Like I think $1 million if you solve them. They've been around for hundreds of years,
Yeah.
but I'm curious what that guy solved. That does sound very familiar. Okay. To find the critical numbers, here's f. So f prime is equal to 2x minus 4. Set this guy to 0 to find it. So this would be 2x minus 4 equal to 0. Solve for x, you get 2, right? Okay.
Yes.
Part B. Find the open intervals of increasing slash decreasing. I guess that sounds kind of weird.
I mean, just intervals works because what else is it going to be an interval of?
Yeah, I guess so. Okay. So we're gonna use the first derivative test and test around 2. So I'm gonna pick 0 and I'm gonna pick 3, I guess. So plug that in here. That would be 2 times 0 minus 4. Very similar to the last one. That is negative. Derivative at 3 would be positive. Yeah, it looks like it's almost the same. So plus. So I'm going to put a little dot here so I know that's the critical. Plus over here. So this would be, is this a minimum or maximum? What do you think?
Minimum.
Yeah, this is a minimum for sure. Okay. So increasing interval is 2 to infinity. decreasing interval is negative infinity to 2. All right. Part C. Apply first derivative test. To find max/min. So we kind of already see it, right? We're at minimum at 2, comma something. Find out what that something is by plugging this into F. So the minimum here. Now let's look at both of these examples on a graph. So we can put a picture on this. Okay, so this current question, it's a parabola pointing upward. So of course it's a minimum, right? It's right there, 2, -4. And we can see what the derivative told us. It said, where's that stupid thing? Right, if we're going downward all the way this way, and over here we change to increasing, that means we have a minimum. So we have that horizontal slope, 0 slope. But anyway, I think that's pretty much all there is. Let me show you the homework questions. Was there anything you wanted to do that you stumped you, or were they all pretty fair?
They were all pretty easy.
Nothing worth looking at?
Nope.
Okay.
Because it was, I mean, just asking for this. Again, like this part, I remember now, back in high school, this was the part where things made sense again.
That's good. That's good. Well, all right, then we can stop here. If the big picture makes sense and you don't have any questions, we can stop a little early. If you look at the syllabus here, we're around here right now. So next week, since you won't be here, we'll just do a ton next week.
Okay.
We should be fine. So Tuesday we'll hit these two, and then Thursday we can hit this one or something like that.
Sounds good.
All right, cool. We'll figure it out. And good luck on your conference. Let me know how it goes.
Thank you. I will. I'm gonna send you that article.
Cool, thanks. Appreciate it.